I have to run right now because I have a meeting, but
Okay.
well, nice to
Yeah.
see you, James. But
Good to see you too. We're live now. So welcome everyone. Thanks for joining to another workshop for the XION BELIEVATHON, which is live on DoraHacks at the moment. Today I'm joined by Wyatt and Andrew from LIT. Great to see you guys.
nice to see you as well.
So just a reminder for everyone, there's 11 days left of the BELIEVATHON, the link to which is in the comments, so you can check out the DoraHacks page for that. It's a great opportunity to get involved with one of the fastest growing layer ones in the space. And this is the perfect opportunity for entrepreneurs who want to turn their ideas into reality, because in addition to the 40K prize pool, there's also access to their accelerator and incubator programs as well. Super star-studded team of judges and people that will get involved with helping you take your project to the next level. So go and check out the hackathon page on DoraHacks for XION BELIEVATHON. As I said, 11 days left, but really delighted to be moving ahead with this workshop series. We've got these two guys from LIT who are going to be doing a presentation, and then we'll wrap things up at the end. So how are you guys doing? Are you ready to kick things off?
Yeah, I'm excited. Yeah.
So we're from LIT. We do decentralized key management as well as like decentralized encryption, and we also have something we call LIT Actions, which is like decentralized compute. You can think of it as like serverless functions, but ran by like a decentralized network. I think to kick off our presentation, I'm going to share a video that is a presentation done by our CEO that kind of like goes over LIT. And how we can do like decentralized secret management for solving various problems.
For this next talk, I want to bring on David from LIT Protocol to tell you about how we can rethink managing secrets on chain. So it's going to be a lot of cool things here. Please welcome David from LIT.
All right. Thank you, Kartik. Hello, everybody. As you can see, my name is David, and today we're going to cover 4 things. Basically, the broad problem space. We'll get into that in a second. The solution we've invented and have had live since February of this year. It's done over 20 million requests. Some examples of various implementations, and then the opportunity for the future. So, to start with the problem space. This is something that everybody knows, whether you're a developer, a product manager, technical or not, and the fragmented nature of our world from a technological perspective isn't just something that technologists know, but every single individual knows this who's a general user. So it begs the question, what's the common thread? What's tying every system together? Because we know the world that we want, which is to have agents, applications, protocols that seamlessly interoperate across every single touch point, platform, network, for the benefit of businesses and individuals. Now, it's not a secret, but it is in fact secrets are the unifying factor here. Whether it's a private key on a blockchain, password on your social media account, YubiKey, an API key to access a B2B service. And this is the specific problem that we have been working on for the past 3.5 years at LIT Protocol, which is a programmable secrets network. And so the big idea here is if you write applications and protocols with functions that dictate where secrets are used across these systems, across these networks and platforms, you create a new class of kind of unlimited composability across all networks. So we'll go into the architecture because this is a non-trivial problem to go after this, no pun intended, but key problem of secret management. Yes, and we'll get into some of these use cases, but as mentioned, the system has been live in mainnet beta since February of this year and processed 20 million requests to date. So as you can see, we've got 3 graphics here, and this is moving in order of scale from left to right. A node, what the network looks like, and then how this scales. And so let's talk about the 4 components over there on one of these single lit nodes. And again, the intent here is for a programmable secret management network where the secret is not managed by a single party, but is a decentralized, distributed, and safe and secure secret. So first you'll see that the outline is the secure hardware. This is encrypted VMs, specifically AMD SEV, which is their secure encrypted virtualization. This is a type of TEE. We've written a specific operating system for this TEE to seal and lock this down, essentially turning it into a black box that the operator of this box cannot get into, because the secret material in there is the red icon, the key share, which is part of a threshold key, which we'll talk about in just a second. And then there's also an execution module and a networking module for data input and output. So moving to the right, up to the network scale, this is a threshold network. The specific methodology here is called multi-party computation threshold secret schemes. The important word there is threshold. This is how secrets are managed in a distributed context. Each of those key shares represents a part of the total key, and in order to generate some operation, like a decryption or a signature from the underlying distributed key, you need, in the case of LIT protocol, 2/3 of the network to sign off on this. And signing off is not something that there's like a human in the loop. This is done in an automated way. We'll talk about a couple specific examples in a second. And basically at this network phase is where we are today. We have a handful of networks live, processing all of these requests, but where we see the world going is towards a key mesh with many, many networks, not too dissimilar to the app chain hypothesis in Ethereum and Cosmos, but in the case of secret management. And so just to talk a little bit more about how this is used to interconnect systems, literally anything can trigger one of these functions where the output, let me say this another way. You can basically take an input from any system, whether it's a user-generated input, whether it's an event that happens on-chain, whether it's an event that happens in an API, to start this process of a request. And then for a given request, those three components are there again, which is computing inside of the TEE, so it's blind, creating a decryption or a signature from the shared key, or fetching data from a blockchain or a user or an API. So functionally, you can think about this as a new primitive. Folks in the past have kind of compared the insight here to Ethereum. Like basically, Vitalik's big idea is that setting up a blockchain is a really big task. Now, if you can make a blockchain programmable with smart contracts, nobody has to set up their own node network because you can just program the chain with smart contracts. There's a similar type of mindset happening here, but rather than having to go set up your own distributed key management network, you can actually just leverage the distributed key and write applications on top of it. And then, of course, you can see the outputs in turn can also go to any other system, and these things can loop over and over and over, and you can create really sophisticated and interesting protocols. And we'll look at a couple examples right now. So this is a little bit related to what we just heard from Jason at Story. This is a project called Verify. It is an IP licensing network from the Blockchain Creative Labs inside of the Fox Corporation. And functionally, the way that it works, they have a Polygon CDK blockchain, and media organizations like Fox and Time, what they're doing with their articles is they are encrypting that article, go back here, to the distributed key, because the public key is public, and then setting a rule around who can decrypt that or view that asset. And so the way that it works specifically is, let's say Fox writes this article, it gets encrypted to the public key, it's stored on IPFS, encrypted so nobody can read it, then somebody purchases that license on chain, let's say that's Bob or an AI company or another media organization that wants to syndicate or reshare that content. Bob, what he's going to do is he signs a message and he does a one-to-many operation to all of those lit nodes that we were looking at earlier. Each of those nodes then independently check the chain. Does Bob own the license to be able to decrypt this content? If yes, each of those nodes use its key share to generate something called a signing share, which you could think of as an authorization. And then there's a many-to-one operation that goes back to Bob. And so Bob collects those authorizations client-side, and now he has the decryption signature as well as the ciphertext and can go ahead and decrypt that content client-side. This is a process called identity-based encryption. You could think about it as conditional or rules-based encryption. Historically, identity-based encryption was performed with a centralized authority who dictates the rules and provisions decryption keys, but in this case, it's being done with this threshold network running inside of secure hardware. And as you can see over on the right side of the screen, I've just included some of the systems that are interlinked, where the chain is managing the license. In this case, they're using IPFS to store the ciphertext. And then their system also has implemented things like Apple and Google for being able to allow users to sign on and sign into this network without having to manage a seed phrase, because the key material for the user is managed by Lit. Now let's take a look at another example. This is a product called Nebula. They're still in development, but what they are building is essentially an on-chain life insurance company where somebody can go ahead and get some life insurance from a wide variety of providers. And what's very interesting about what they're doing, you can see I've got on the right side the image representing the user. The user, Alice, goes ahead and inputs all of the requisite data required to get life insurance. What are her pre-existing conditions? Is she a smoker? What's her age? What's her location? The standard form that would be required to get life insurance. Now, instead of sending that private, personal, identifiable information to all of the agents, what the Nebula team is using Lit for is that information is encrypted and stored on IPFS, and then to determine the risk score, we can kind of think about it simply in like a 1 out of 10 risk score in terms of what should the premium for Alice be. That content is decrypted inside of Lit, inside of the secure hardware environment. Then they have a risk score model that iterates over Alice's data 100, 1,000, 10,000 times, and the output is that 1 out of 10 score around how risky is it to insure Alice in this case. And now the agents that are underwriting the life insurance can give Alice a quote without knowing her pre-existing conditions, without knowing if she's a smoker, things of that nature. That private information remains private to Alice. This, of course, gets really interesting. Healthcare, I think, is the final boss of Web3 in many ways. And so this notion of being able to compute over personal identifiable information in a privacy-preserving way starts to get really exciting. And the last example, coming back to the crypto world, this is an application called Genius Terminal. They like to say that they're sex on chain. It's basically a fully chain abstracted application. And so you can see what I'm doing here is, let's see. Oh, I don't think the full GIF loaded, unfortunately. But basically, sorry about that. So the swap that I wanted to show is moving from USDC on Base into a meme coin on Solana. And unfortunately, I don't have the ability to show it here, but the swap took 2 seconds. And the functional architecture that they have here is there's actually 4 programmable wallets involved in making that swap happen in less than 2 seconds. There's a user wallet on Base, there's a protocol wallet on Base, there's a protocol wallet on Solana, and a user wallet on Solana. And the user wallets are connected to the same authentication, in this case, sign in with Apple. And so the transaction gets simulated. Oh, I need to take my USDC on Base, and it needs to go to the orchestrator wallet on Base. Then the orchestrator wallet on Solana needs to hit a local DEX to buy that meme coin and then send it to the user wallet on Solana. So that transaction gets simulated, the user clicks swap, and all of those actions happen in parallel. So this is basically equivalent to the type of experience that somebody would have on a centralized exchange, although, of course, without things like KYC or trusting a centralized custodian. If you want to check this app out, they're doing their main launch in a couple weeks, but you can go to geniusterminal.com/home and use the code GETLIT if you want to check out their beta. That's all capitalized. And that's where things are today. Now to just talk a little bit about the opportunity ahead, these are two graphics that you may have seen in the past. The one on the right is from situational awareness, a really nice overview around where are we in the state of AI, or excuse me, the one on the left. And the one on the right is from Vitalik's post about his version of defensive techno-optimism. So we'll just talk about these two graphics for a moment to set the context for what's next. What's happening there on the left is counting the order of magnitudes of improvement in LLM models. And the prediction from this particular paper is that in about 2 to 2.5 years, basically the work that is done by AI researchers and AI implementers will be good enough, will be able to be done by the AIs themselves. This is like the AGI moment that many people are talking about, that we're heading like pretty rapidly towards, and this is where the speculation starts. And this works well with this kind of framing that Vitalik has shared around defensive techno-optimism. As you can see in Vitalik's view, there's both abundant and delightful futures ahead that are possible, as well as very, very scary ones. And so you can see the prompt here is, how do we think about tamper-proofing a solved world, a world where we do have just much abundance thanks to machine intelligence? And so I think this is really the opportunity ahead. And for people who are kind of clued into this view now, recognizing that the capacity to build applications that interweave systems, that create a space, a portal, a method for individuals to control their own data, their own secrets, with intelligence associated with their own data and secrets before that agent goes and interacts with the rest of the web, really feels like the best possible outcome for the machine intelligence world that we're heading towards, because the alternative is basically just a much scarier and wilder version of what happened with Web 2, which is people interacting with walled gardens. They don't have fundamental control over their data and therefore are prone to manipulation, which we have continued to see. And so we do have prizes for the hackathon this weekend. They are oriented towards decrypting items inside of Lit and using them in this agentic coin that is related. But I just want to reiterate this kind of core idea that it really feels like the opportunity is now to give people access to their own data and making that data really, really useful, whether it's in the context of finance, like building an automated method for investing in derivatives with the technical analysis done in an automated way, or in the context of user-owned data for things like smarter recommendations. We've just seen some really fascinating work happening from people who have kind of taken this as a fundamental perspective. And we'll be here all weekend. And so with that, you can find me and you can find us on.
Awesome. Yeah, thank you guys. That was, again, a presentation done by our CEO for ETHSF, but yeah, conveys the message of what we're doing here at Lit pretty well. So I wanted to share that with you guys. Additionally, I'm going to share my screen. Okay, so this is our documentation that'll be really useful for the hackathon. Here we have a section called Making Your First Request. This is kind of like a guide that we targeted for users who are onboarding with us. It's going to walk you through connecting with Lit, generating what we call session signatures, which is what's going to allow you to make requests to the Lit network to do things like decryption, to execute Lit actions. We walk into like installing our SDK, and then we walk into making your first decryption, has all the code examples, makes it really easy to follow along with, and then also doing like a decentralized signing example. Afterwards, we have a couple other pages that you can walk through, but under our guide section, we have an area dedicated to the encryption and access control, which is what David mentioned in his talk. It was you can have a piece of information that is encrypted using the MPC network, and then you have this identity-based access control. When you satisfy these access control conditions that you specify when you encrypt the data, you'll get the signature from each of the Lit nodes that acts as like the decryption key for your specific information that was decrypted. And you only get that, of course, if you satisfy the access control conditions. In addition, we also have decentralized compute using what we call lit actions. And this is basically a JavaScript VM that uses the Dino runtime and allows you to execute what are essentially like smart contracts, but are written in JavaScript on the lit nodes inside of their TE, the trusted execution environment. So you can run arbitrary JavaScript that can reach out to APIs through HTTP using like the fetch API from JavaScript. You can read data from off-chain, on-chain. You can use that data however you want inside the lit action. And then you can also do like decryption inside the lit action. You can sign with like a decentralized key that we call a PKP, a programmable key pair. Yeah, basically the lit actions are kind of like a sandbox for you in JavaScript that lets you leverage the lit network. And so those are the main pages that are probably going to be relevant for the hackathon. Aside from that, we have, one second, sorry. We have a code repository called the Developer Guides Code on our Lit Protocol GitHub. And each one of these is their own kind of like self-enclosed code example that kind of walks through various things like doing a lit action that uses the fetch API. We have one for our Telegram mini app example, which Andrew is going to go over in more detail, but this we also think is relevant as it's like one of like the bonus prizes for the XION hackathon. Andrew, would you like to continue on with walking through the Telegram mini app?
Yeah, absolutely. Thank you for that, Wyatt. Let me just share my screen really quick. So yeah, this is just an example of a simple Telegram mini app we set up. I'll walk through what it looks like on our side. So you'll connect with MetaMask first, and then for this example, we're just minting a programmable key pair. This only has to be done once, and then we're adding in this step Telegram as a custom auth method. And then, as Wyatt mentioned before, we're generating session signatures to authenticate our session with the lit nodes. Pretty simple example. Wyatt referenced it previously here. What it's kind of doing is we're taking the Telegram authentication data and pretty much adding it as a permitted authentication method to our PKP, which is kind of like a wallet on the lit nodes. The kind of logic matches the Telegram authentication logic. So that takes your user data and has to match a certain hash. Why it's useful? Because once you mint the PKP initially and cover the gas fees within EOA, you can then use that Telegram auth method to authenticate yourself for that PKP and use it for various functions. I guess, yeah, if you'd want to see more about that example, our steps here in the developer guides code that I mentioned previously are pretty comprehensive. It walks you through even setting the bot up with the bot father on Telegram. And then you can go through, clone the existing repository, set the environment variables up with Vercel, and then deploy the application. Pretty comprehensive. We try to make the steps as explainable as possible. But if you go through this example and have any questions, just let us know.
Awesome. Thank you, Andrew. Yeah, and I think that concludes our talk. If you have any questions and want clarification on any of our features or like want a specific code example to do X, Y, or Z, please feel free to reach out to us on our Discord or our Telegram. We're actively providing support there, and I want to emphasize that we do like to make code examples. If you want to like do like a specific scenario, we can either point you to an existing one that we have, or we can write up one for you, so that way we can make your life easier with implementing lit.
Thanks, Wyatt, and thanks, Andrew, for that presentation. That's really good, and nice to hear from your founder as well with the video at the start. Just going to reiterate for everyone, there's 11 days left for the hackathon, so make sure you get registered. You can submit your project unfinished and then keep editing it up until the submission deadline. So I'd recommend registering and getting your project submitted so it's there, and then you can keep changing it, adding more information, everything else up until the deadline in 11 days, today being the 4th of December. Super great opportunity for this hackathon. And just to note that all the docs for all of the partners, but also especially for Lit, are available on the details page of the DoraHacks hackathon listing. So go and check that out if you want to read the docs. We've also put information in the comments of this video. So thanks everyone for tuning in, and thanks Wyatt and Andrew for the presentation today.
Yeah, thank you, James. Thank you, everybody.
Yeah, thank you for having us.
All right, thanks guys.